Assalamualaikum. We are from Group 9 who want to present about Mohr Circle. My name is Khairul Hasif, and with the other member of Group 9 is Mohammad Firdaus, one Mohammad Syafiq, and Mohammad Adib Iqbal. Before we know about the Mohr Circle, we need to know about the stress and strain. Stress and strain are the two terms in physics that describe the force causing the deformation of the object. Deformation is known as the change of shape of an object by application of the force. Very small force can also cause deformation. The object experience it due to external force. For example is the force might be like squeezing, twisting, shearing, ripping, or pulling the object apart. So what is stress? Stress is the force applied per unit area. The formula is stress equals to force over area. Stress is measured by unit Newton per meter square. The ratio of internal force produced when a substance is deformed to the area where force is applied is known as stress. At equilibrium, the internal force is equal to the magnitude of the external applied force. And what is strain? Strain is the ratio of the amount of deformation experienced by the body in direction of force applied to the initial size of the body. The formula of the strain is strain equals to elongation over length. Strain is the ratio for the change of shape or size to the original shape or size. It is expressed in number as it doesn't have any dimension. Next, we go to stress-strain curve. The material stress-strain curve represents the relationship between stress and strain for material. The strain value are plotted on the curve corresponding to the stress incurred by different load on the object. They have a few stress-strain graph, which is first is proportional limit. The region in the stress-strain curve that observes the Hood law is known as proportional limit. According to the limit, the ratio of the stress and strain provide us the proportionality constant known as Young modulus. Second is elastic limit. Elastic limit is a maximum stress that substance can endure prior to permanently being deformed. When the load acting on the object is completely removed, the material returns to its original position. That point is known as object elastic limit. Next one is yield point. The point at which the material starts showing to deform plastically is known as yield point of the material. Once the yield point of the object is crossed, plastic deformation occurs. There are two types of yield point, which is upper yield point and lower yield point. Next is ultimate stress point. The point at which a material endures maximum stress before failure is known as ultimate stress point. After this point, the material will break. Last one is breaking point or fracture point. In the stress-strain curve, the point at which the failure of the material takes place is known as breaking point. That's all from me. I will pass to the next presenter. Thank you.
Okay, so let's continue. Before that, my name is Mohamad Iqbal Zalami, and I will share about what is transformation of stress and strain. So let's continue to the introduction. The most general state of stress at a point may represent by 6 components, which is this 1, 2, 3, 4, 5, 6. Same state of stress is represented by a different set of components if axes are rotated. The first part of the chapter is concerned with how the components of stress are transformed under a rotation of the coordinate axis. The second part of the chapter is devoted to a similar analysis of the transformation of the component of strain. State of plane stress occurs in a thin plate subjected to forces acting in the mid-plane of the plate. State of plane stress also occurs on the free surface of a structural element or machine component. For example, at any point of the surface not subjected to an external forces. So we move to the next one, which is transformation of plane stress. Consider the condition for equilibrium of prismatic element with faces perpendicular to the x, y, and x prime s. So we look to this formula, summation fx prime equal to 0 and is equal to sigma x delta A minus sigma x bracket delta A cos theta minus tau xy bracket delta A cos theta bracket sin theta minus which delta sigma y bracket delta A sin theta bracket sin theta minus tau xy bracket delta A sin theta cos theta. So for the summation of fy prime equal to 0, it's equal to tau x prime y prime times delta A plus sigma x bracket delta A cos theta bracket sin theta minus tau xy bracket delta A cos theta bracket cos theta and minus which sigma y bracket delta A sin theta cos theta plus tau xy bracket delta A sin theta. And for the summary, we can write this equation to yield, which is as the shown below. Like for x prime, y prime, and tau x prime, y prime. Sigma x prime, sigma y prime, and tau x prime, y prime. So we move to the next one, which is principal stress. The previous equation are combined to yield parametric equation for a circuit. So for this formula, as we can see on this slide, bracket sigma x prime minus sigma average bracket square plus tau square x prime y prime is equal to r square, where for as we can summary is sigma average is equal to sigma x plus sigma y divided by 2. For your information, one of the formula is r square, r is equal to square root of bracket sigma x minus sigma y over 2. Principal stress occur on the principal plane of stress with zero shearing stress. The formula, as we can see, sigma max or minimum is equal to sigma x plus sigma y divided by 2 plus minus square root of sigma x minus sigma y over 2 square plus tau square xy. From the picture, we can collect the information, which is this is the sigma x prime and this is tau x prime y prime. We can get it from here. So from the question, we need to analyze where is the value. So this is mean by sigma minimum and from O to B, while the sigma max is from 0 to A. We also can use tan 2 theta P equal to 2 tau xy per sigma x minus sigma y. And disclaimer, we need to define two angles separate by 90 degree. To calculate maximum shearing stress, we need to use this formula. We need to use this formula. And for your information, sigma x prime is equal to sigma average. So let's look to this formula. Tau max is equal to r and it equal to square root of bracket sigma x minus sigma y per 2 square plus t square xy. We can use tan 2 theta as equal to negative sigma x minus sigma y over 2 tau xy. Note, define two angles separated by 90 degree and offset from theta p by 45 degree. So in order to solve this question, we also can use this formula, which is sigma prime is equal to sigma average is equal to sigma x plus sigma y per 2. So for the Mohr circle for plane stress, with the physical significance of Mohr circle for plane stress established, it may be applied with simple geometric consideration. Critical values are estimated graphically or calculated. For a known state of plane stress, sigma x or sigma y and tau xy, plot the point x and y and construct the circle center at the C. We can use the formula as shown in the slide below. For your information, the direction of rotation OX to OA is the same between the CX to CA. Mohr circle for plane stress. With Mohr circle uniquely defined, the state of stress at other axis orientation may be depicted. For the state of stress at an angle theta with respect to the xy axis, construct a new diameter x prime y prime at the angle 2 theta with respect to xy. And normal and shear stress are obtained from the coordinate xy x prime y prime. Lastly, the Mohr circle for centric axial loading, as we can see, we can use this formula. Sigma x is equal to P over A, sigma y is equal to tau xy, which is equal to the 0. Same with this formula is sigma x equal to sigma y equal to tau xy and is equal to P over 2A. And for the Mohr circle for torsional loading is a different. So as we can see, this formula is sigma x is equal to sigma y is equal to 0, but the tau xy equal to Tc over J is different with the axial loading. So the lastly is, as for the torsional loading, as we can see, sigma x is equal to sigma y is equal to Tc over J, and the tau xy is equal to 0. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Syafiq bin Alwi. I'm going to present about what is Mohr circle. Basically, it is the transformation equation for plane stress can be represented in graphical form by a plot known as Mohr circle. This graphical representation is extremely useful because it enables you to visualize the relationships between the normal and shear stresses acting on various inclined planes at a point in a stress body. Using Mohr circle, you can also calculate the principal stress, maximum shear stress, and stress on inclined planes. Next, I will present about derivation of Mohr circle. If we vary theta from 0 degree to 360 degree, we will get all possible values of sigma x1 and tau x1 y1 for a given stress state. Eliminate theta by squaring both sides of 1 and 2 equation and adding the equation together. Let's see the equation. Bracket sigma x1 minus sigma x plus sigma y over 2 bracket power of 2 plus tau x1 y1 power of 2 equal to bracket sigma x minus sigma y over 2 bracket power of 2 plus tau xy power of 2. And then we define sigma average and R. Let's see the sigma average equation. Sigma average equation is sigma average equal to sigma x plus sigma y over 2. And then the R equation is R equal to square root bracket sigma x minus sigma y over 2 bracket power of 2 plus tal xy power of 2. After that, we substitute for sigma average and R to get an equation, which is the equation for a scale bracket sigma average comma 0 bracket and radius R. The equation, which is the equation is sigma bracket sigma x1 minus sigma average bracket power of 2 plus tal x1 y1 power of 2 equal to R power of 2. Thank you. That's all from me.
Okay, Assalamualaikum. So I will continue with Mohr circle equation. So Mohr circle equation is the circle with that equation is called Mohr circle, named after the German civil engineer Otto Mohr. He also developed the graphical technique for drawing the circle in 1882. So the formula is sigma x1 minus sigma average bracket by power of 2 plus tall x1 y1 power of 2 equals to R2. So this is the formula for Mohr circle equation. We continue to constructing Mohr circle procedure. So basically the first step we to do is draw a set of axes with OX as positive to the right and tall x 1 y as a positive downward. Means this is the first one of the OX1 and this is second for TX1 Y1. Second we do locate point A. This is point A representing the stress condition on the X face of the element by plotting its coordinates. That is sigma X equals to 0 and Tx1 Y1 equals to Tx Y. Note that point A on the circle corresponds to theta 0 equal theta equals to 0 degree. Now we locate point B representing the stress conditions on the y face of the element by plotting its coordinate theta as sigma x equals to sigma y and tall x1 y1 equals to negative t tall xy, and then draw a line from point A to point B, a diameter of the circle passing through point C. That means the center of the circle. Point A and B are not opposite ends of diameter and therefore 180 degree apart on the circle. Using point C as the center, draw more circle through points A and B. This circle has radius r. The center of circle C at a point having coordinates sigma x1 equals to 0 equals to sigma average and cx1 y1 equals to 0. So that's for my explanation for constructing Mohr circle. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. With me again, one Mohammad Syafiq bin one Alwi. Now I'm going to explain how to solve the example question that on VLE. So this is the question, as we know that the question that we get lah. So first and foremost, we need to find two coordinates, which is x face and y face. So in this question already give all the coordinate that we want. As you see in this slide, I already plot x face and y face. We need to find the midpoint between two coordinates, which is negative 25 MPa. Which is the negative 25 MPa is the average normal stress. And how to get the radius? So the way to get the radius, we square root the 475 power of 2 plus 530 power of 2. And then the radius that we get is 711.71 MPa. Now, we want to find theta to reach principal stresses. The theta that we want is 24.07 degree, as you see. Next, we want to find normal stress, which is radius minus midpoint. And we got two values sigma, which is sigma 1 and sigma 2. Sigma 1 that we get is 6 at 6.71 MPa, and sigma 2 is 736.71 MPa. So the last questions, we calculate the new degree after rotation. Okay, we got 44 degree. So we used to find x and y by using sin and cos. After the value for y is the value for tal xy. For the theta x, the x value we plus with midpoint. And then for the theta y, we minus 25. So, this is the answer that we get. So that's all the explanation from me representing my group. Thank you so much for letting you hear. Assalamualaikum warahmatullahi wabarakatuh.